mission and for the subsequent stage is only in a temporary location, so it doesn't have its standard power and data connections. JAXA built a special laptop for the crew so they can check the health of the JLP. I've got a video here that'll show you a little bit of what the JLP looks like. It's basically a logistics and storage module, similar to all the other station modules. It's attached by a common berthing mechanism. We'll use the shuttle arm to install it. It's got a single grapple fixture. It has an external facility unit. This is used to house payloads for future operations. If I could have the graphic of the installed JLP, please. This image shows you where we're going to place the JLP on node 2, and then I've got a shot of the inside of the JLP. This shows you the interior. It's got 8 racks, many of which will be transferred over to the GEM module on the next mission and used for its activation. So much of what the crew will be doing on this mission is preparing the racks for that activation. The SPDM is a robotic device that's going to help us with station maintenance. It's capable of removing and replacing ORUs. I have a graphic to show you what it looks like after it's assembled here. It's got a main body, and on the bottom of the main body there's a latching end effector. This is basically the same type of latching end effector, or lead, that we have on the station arm. This allows us to place it on any one of the grapple fixtures on the station. On top there is a grapple fixture. This allows it to be handled and flown from the station robotic arm. It has 2 arms, and on the end of each arm there's a specialized end effector. It's called the ORU Tool Changeout Mechanism, or OTCM. This allows the SPDM to handle ORUs and tools. And on the front of it here you can see there's an ORU platform. It kind of looks like a cylindrical device. That allows us to temp stow ORUs on it as we're doing changeouts. It also has 5 cameras, which are not pointed out in this picture here. I've got just a short video that'll show you how SPDM moves. The main body can rotate around to allow us to position the arms at a work site. Each one of the arms has 7 joints. That is similar to the design of the station arm, or the Canada 2 arm, which also has 7 joints. This allows us to precisely position the SPDM arms for tool grasping and ORU handling. With that, I'll go ahead and pick up with the mission overview. After docking, the first thing we do is transfer the Space Lab pallet over to the mobile base system on the station. If I could get the video of that transfer. Let's see, this is the JLP installation. This will be done following EVA-1. The shuttle arm, flown by Takao Doi, will install the JLP. It's a pretty impressive looking maneuver with all the twists and turns that you see there. That's needed to get the berthing mechanism in alignment with node 2. After it's aligned, the CBM will be operated by Bob Benken and Leo Aharts to do the final bolting of the JLP. So that was actually a clip there following EVA-1, so let me back up and talk to you about the Space Lab pallet. That's going to be grappled by the station arm. That'll be based off of node 2, and it'll be installed on the P1 truss, which is where the MBS is located. Here's the graphic. So this is showing the removal of the Space Lab pallet from the payload bay. You can see on the P1 truss there's the MBS. The MBS has a latching end effector on it. It's called the Payload ORU Accommodation. That will be used to grapple the second grapple fixture on the Space Lab pallet, and then the station arm will release it. Could I get the graphic of the SLP on the MBS? This shows you a closer up view. In green here you can see the MBS and the POA and the Space Lab pallet attached to it. All of the components that you see there in yellow are part of the SPDM. It'll stay in this configuration through SPDM's assembly, and then we'll return the Space Lab pallet back to the payload bay. Let's see, that takes us to Flight Day 4, which is EVA-1 with Rick Lenahan and Garrett Reisman. The main objectives of this EVA are to get the JLP ready for transfer over to station and to start the assembly of the SPDM. The crew will start off the EVA in the payload bay. They'll demate power cables from the JLP, and then they'll head to the SLP to start the SPDM assembly. What they'll be doing is installing the OTCMs on the end of the SPDM's arms. Station robotic arm assists us with that task, and when we're done with the station robotic arm, we will use the shuttle arm to install the JLP. That night, after the JLP is installed, we'll pressurize the vestibule between the JLP and Node 2 and do a leak check. On flight day 5, we'll ingress the JLP and do some of its initial outfitting. That includes starting up the ventilation and moving emergency equipment into the JLP. For the remainder of the mission, the crew will spend a lot of time working in JLP to reconfigure the racks and to get all of the items pre-gathered for Flight 1J. Also on flight day 5, we hand the OBSS off to the shuttle arm. The station arm will take it out of the bay, hand it off to the shuttle arm, the same thing we commonly do on flight day 5 for these missions. If we need to do a focused inspection of the orbiter's TPS, we'll do that on this day as well. Flight day 6 is EVA 2 with Rick Lenahan and Mike Foreman. This EVA is dedicated to the assembly of the SPDM. The two arms will be taken off of the pallet. That will allow us to pivot the main body of the SPDM up, and then we'll install the two arms onto the main body. At the end of the EVA, we'll take thermal covers off of the SPDM. This EVA is scheduled for 7 hours, so it's fairly long. Typically, our EVAs are scheduled for 6 hours and 30 minutes. Flight day 7 begins the checkouts of the SPDM. We do some checkouts overnight, and then during the crew work day, they'll do what's called a brake run-in to run the brakes and make sure they're functioning properly following launch, and then they'll reconfigure arm number 1 for access during EVA 3. Flight day 8 is EVA 3 with Rick Lenahan and Bob Benkin. On this EVA, we'll complete the assembly of the SPDM and we'll transfer the ORUs over to station. After the assembly of SPDM is complete during the early portion of the EVA, the crew will take Missy 6 and transfer it over to the Columbus, and I have a graphic here that shows you where the Missy 6 is installed. You can see at the end of the Columbus module there's some structure there. That is where the two experiment packages will be attached. After Missy 6 is transferred, the crew will transfer over the SSRMS yaw joint and the two DCSUs that Mike pointed out. Those will both go onto the ESP2 pallet. In the top left corner there, you see the spare yaw joint. The bottom right corner has the DCSU, and the bottom left corner shows you an example of what Missy looks like. At the end of EVA 3, the station arm will grapple the SPDM and remove it from the pallet. Flight day 9 will stow the SPDM on the lab.